A very good morning to all of you. So in the today's class, we are able to discuss about the representation of the various processes on the Mollier diagram. So in the previous class, we discussed about the constant volume process representation on the Mollier diagram. So in the today's class, we will discuss about the remaining processes, that is a constant pressure, constant temperature, adiabatic and polytropic processes representation on the Mollier diagram. So the motivation is basically we have to know how to represent the various processes on the Mollier diagram. So I'm expecting the outcome from this particular the lecture is nothing but after completion of this particular lecture, every student should be in a position to evaluate the properties of the steam from the Mollier chart to find the performance of a thermal power plant under the given conditions. Now, let us go to the second important process, that is a constant pressure process or the isobaric process. How can you represent or how can you find out the important properties of the steam? So let us say that whenever it is having the wet steam, so we are having V1 is equivalent to X1 into Vg, and the final volume of the steam is also is equivalent to X2 into Vg. And whenever it is the dry saturated steam, so automatically X2 will be equivalent to 1. So V2 is equivalent to 1 into Vg. So that will be equivalent to V2 is equivalent to Vg. If the final condition of the steam is equivalent to superheated, so automatically V2 will be equivalent to V superheated. So that is, if the initial condition is the wet steam, we can find out the specific value by using this particular formula. And if the final condition of the steam it is equivalent to is the dry steam, then the x2 value is equivalent to 1 in this particular formula. So whenever you are substituting here, V2 is equivalent to Vg, and here V2 will be equivalent to V superheated. And how can we find out the work done? That is P into dV. So because the units are basically in the kilojoules per kg, we are multiplying with 100. So 100 into P into V2 minus V1. So that is the work done formula. So the next one is the change in the internal energy. That is always I told you that H is equivalent to U plus PV. So from this we are able to find out U is equivalent to H minus PV. So since the units are in the kilojoules per kg, we are multiplying with is 100. Use the formula to find out du is equal to U2 minus U1. And from the first law of thermodynamics, we are able to find out delta Q is equal to du plus delta W. So find out the values of the U2 and U1 and W. So here we are able to find out it is equivalent to H2 minus H1. So now based on this particular constant pressure process, let us solve one problem. So he has given 1 kg of the steam at a pressure of 17.5 bar. So the initial condition is given as the 17.5 bar, and the dryness fraction value are also given. So that's why the initial condition is basically the wet steam, and it is heated at a constant pressure until it is completely dry. So that is dry saturated steam, the X2 value is always equivalent to 1. So determine the increase in the volume, the quantity of the heat supplied, and the change in the entropy. So go to the PV diagram, TS diagram as well as the HS diagram. So first of all, our duty is to locate point number 1 as well as the point number 2. So here, how to locate the point number 1 on the HS diagram? So here, the pressure value is given as the 17.5 bar. So go to the Mollier diagram and identify the 17.5 bar line. So it is the 17.5 bar line. And minimum two properties are required to locate a point. So here the dryness fraction value is given as a 0.95. So dryness fraction line is passing like this. So this is x1 is equivalent to 0.95. So wherever this constant pressure and the dryness fraction both are intersecting with each other, locate this particular point as point number 1. And next he said that it is a constant pressure, it is heated at a constant pressure. So because it is a constant pressure line, so just you follow the same line until it reaches the dry saturation line, because he said that until it is completely dry. So this is my point number 2. It is my point number 2. So once you located the point number 1 as well as the point number 2, locate what are the values of H1, H2, S1 as well as the S2 from the Mollier chart. So the same thing is listed here. H1 value, H2 value, S1 value and S2 value. And what is the value of the increase in the value? So because initial condition is wet stream, so V1 is equivalent to X1 into Vg, because Vg is known to you from the Mollier diagram or from the stream tables. And V2, because it is a dry saturated stream, so V2 is equal to Vg. So increase in the value is equal to V2 minus V1. So this is the answer for the first bit, that is for the increase in the value. And next one is asking about the quantity of the heat supplied. So heat supplied formula in the constant pressure process is always equivalent to delta H. So our duty is to first of all find out the H1 and H2. So because it is the wet stream, H1 is equivalent to HF1 plus X1 into HFG1. Substitute the values, you will get the answer. And the next one, the final condition is the dry stream. So simply H2 is equivalent to is a Hg2. So Hg2 value is equivalent to so and so. So now the change in enthalpy values will be equivalent to 95.8. And similarly, the change in the entropy also in the similar direction. It is equivalent to S2 minus S1. S1 is the wet stream. So find out the wet stream entropy. And next one, it is the dry stream. So dry stream entropy is nothing but it is the Sg2. So the change in the entropy value is equivalent to 0.2 kilojoules per kg. So by doing all these things from the stream tables or from the Mollier chart, we are able to find out that the final condition of the steam, so that is equivalent to T superheated or the T superheated is equivalent to 154.8 degree centigrade. So that is, he has given the corresponding pressure of the 5.4 bar. So the corresponding pressure of the 1 bar, these are the values, and at the 1.5.4 bar, these are the values. So from 5.4 bar, we are able to know that the corresponding saturation temperature is equivalent to 154.8 degrees centigrade. So automatically it is equivalent to 154.8 degrees centigrade. And similarly, we can find out the change in the internal energy. Du is equivalent to U2 minus U1. So these are the values. And the change in the entropy is equivalent to 7.6635 kilojoules per kg Kelvin. The another process is the constant temperature process, which is also known as the isothermal process. Just you recollect the fundamentals of the engineering thermodynamics. So for the isothermal process, temperature is always equivalent to constant. When temperature is equivalent to constant, we know that pressure is always inversely proportional to the value. So PV is equivalent to constant, or PV by T is equivalent to constant. It is known as the Boyle's law. So based on the Boyle's law, now let us solve a problem based on the constant temperature process representation. So just you go through the problem. He has given P1 is equal to 5.4 bar, and initial condition of the steam is wet, that is the dryness fraction is given as the 0.8. X1 is equal to 0.8. Expands in a cylinder reversibly and isothermally. So he has given isothermal expansion process to 1 bar. So P2 is equal to 1 bar. So now he's asking all these particular the 5 important points. The only thing is that how can you mark the point number 1 and point number 2 on the Mollier diagram? That is very important one. Now let us locate point number 1 on the Mollier diagram, that is on the HS diagram. So now for the locate the point number 1, he has given the 5.4 bar constant pressure line. So go to the Mollier chart wherever the 5.4 bar line is passing. So this is the 5.4 bar line. And I had already told you that minimum two properties are required to locate a point. So x1 is equivalent to 0.8. So both are intersecting at this particular point. So from this particular point number 1, find out what is the value of the H1. Similarly, also locate what is the value of S1. And next he is saying that is expanding isothermally. So expanding isothermally means, so after locating this particular point number 1, so where these constant temperature lines are basically passing. So let us say that, so it is a constant temperature line is basically passing like this. Now it is expanding to 1 bar. So 1 bar line is passing like this. So 1 bar line and here the constant temperature line, both are intersecting at this particular point. So this is the point number 2 and this is my point number 1. So from the point number 2, locate what is the value of the S2 and similarly what is the value of H2 from the Mollier diagram. Then you simply substitute in the values. We are able to get what is the value of the heat transfer, what is the value of the work done, and what is the value of the change in the entropy. So the next process is the hyperbolic process. Hyperbolic process is also nothing but PV is equal to is a constant. So whenever we are having both the conditions are in the wet stream, so then the x2 value can be found out by using this particular equation. So which is also one of the important Charles law, that is the V by T is equal to constant. So based on this we are able to find out the work done. The work done formula is equal to so and so. The change in the internal energy, just it is nothing but just a substitution of the values of the U1 and U2 in this particular one. So it is also equivalent to H2 minus H1. So delta heat absorbed, that is the delta Q is equivalent to du plus delta W. So this is the formula to find out delta Q. So now based on this hyperbolic process, let us solve a problem. He has given steam at a pressure of 10 bar, so P1 is equivalent to 10 bar, and the dryness fraction value is X1 is equivalent to 0.9. So next is hyperbolic expansion process is taking place up to atmospheric pressure. So it is a 1.01235 bar, and Cp value is given as 2 kilojoules per kg Kelvin. So go to the steam tables or go to the HS diagram. Locate in the similar manner is the point number 1 as well as the point number 2. So find out what is the value of the H1, H2, S1 and S2. So substitute in the respective formulas of the work done, and find out what is the value of the work done is equal to 400 kilojoules per kg. And similarly the enthalpy, the change in the enthalpy also. So substitute all the values in the respective equation and find out what is the value of the V superheated. V superheated is equivalent to 1.726 and T superheated is equivalent to 385 Kelvin, and X2 value is equivalent to 1.032, that is slightly superheated. So similarly, you find out what is the values of the H1 and H2. So DH is equivalent to H2 minus H1 because initial condition is the wet steam. So H1 is equivalent to HF1 plus X1 into HFG1, and the final condition is the superheated steam. So you know the formula of the superheated steam enthalpy. So substitute all the values, you can find out the H2 value, and here it is the H1 value. The change in the enthalpy is equivalent to 125.2. And similarly, the change in the internal energy, it is also equivalent to the change in the enthalpy. That is, in this particular process, du is equivalent to dH. So automatically, the same value equals to for the change in the internal energy. And to find out the heat absorbed, always go to the first law of thermodynamics. That is, the delta Q is equivalent to du plus delta W. So find out all the values. You can find it as delta Q is equivalent to 525.2 kilojoules per kg. The next one process is known as the reversible adiabatic process, which is also known as isentropic process or constant entropy process. So for the constant entropy process, we know that S1 it is equivalent to S2. So if both the initial and final conditions are wet steam, so we know that S1 is equivalent to SF1 plus X1 into SFG1, and similarly the final condition is also wet steam. It is equivalent to SF2 plus X2 into SFG2, and by using this particular the Charles law, we are able to find out the unknown, the specific value or the temperature of the superheated steam. Now based on this particular the process, let us solve one important problem. So he has given the P1 is equivalent to 20 bar and the superheated temperature is equivalent to 350 degrees centigrade, and it is adiabatically expands adiabatically to a pressure of 1 bar. So that is P2 is equivalent to 1 bar. The steam is dry saturated at the end of the expansion. That is X2 is equivalent to 1. That is, it is a dry saturated steam. And here the initial condition is the superheated steam. Final condition is the final condition. So final condition is the dry steam, and the initial condition is nothing but is the superheated steam. So go to the steam tables or go to the Mollier chart and locate these particular points and find out the H1, H2, S1 and S2 values. So all these are basically plotted here. So these are basically obtained from the steam tables or from the Mollier diagram. Now our duty is to only substitute in the respective formulas. So that is the U is equivalent to H minus 100 into PV. So initial condition is the superheated steam. So H1 will become H superheated and V1 will become V superheated. So substitute all the values here, you are able to get this is the U1 value. And whenever you are finding out the U2 value, because we know that H2, because it is a dry saturated steam, so H2, it is nothing but Hg2. It is nothing but Hg2. So V2 is nothing but is a VG2. So substitute all the values, you are able to get U2. So du U2 minus U1, that is equivalent to, there is a decrease in the internal energy of the 355.3 kilojoules per kg. And is the work done during the adiabatic process, delta Q is equivalent to du plus delta W. So the work done will be equivalent to minus of du, that is 355.3 kilojoules per kg. And the change of the entropy, because the initial condition is the superheated condition, S1 is equal to S superheated, and S2 is equivalent to Sg2 because it is a dry saturated state. So the change in the entropy value is equivalent to 0.4 kilojoules per kg Kelvin. Now, the T superheated and work done, internal energy, heat absorbed, all these things, formulas are basically given. So now the last process is basically the polytropic process, Pv to the power of n is equivalent to constant. So it is exactly similar to the reversible adiabatic process. So only thing is that, so gamma is basically replaced by n. So Pv to the power of n is equivalent to constant. So x value can be found out by using this particular formula. And let us solve a problem on the polytropic process also. So go to the problem and write down the given data. So P1 is equivalent to 1 bar, X1 is equivalent to 0.8, that is the initial condition is the wet steam, and P2 is equivalent to 10 bar, and he has given the polytropic index value is equivalent to is a 1.2. So now go to the steam tables and go to the Mollier chart and find out all these particular the values. So from this particular one, the final condition is basically known that x2 is equivalent to 0.86. That is, it is less than 1. So whenever it is less than 1, we can say that it is wet steam. If it is equal to 1, it is the dry steam. If it is greater than 1, we can say that it is the superheated state. So here the first condition is fulfilled. So the final condition is nothing but is a wet steam, because here only the initial condition is given as a wet steam, but we don't know what is the final condition of the steam, whether it is a wet or dry or the superheated. So that's why by using the basic important polytropic equation, governing equation, P1 V1 to the power of n is equal to P2 V to the power of n. So since we don't know what is the value of the V2, whether it is a wet or dry or superheated, but simply we have taken it as a wet. So from this we are able to find out x2 value. So that is based on the x2 value only we are able to say whether it is a wet or dry or superheated. So since the initial condition and final condition both are wet conditions, so find out U1 of the wet steam, that is equal to 2088.5 kilojoules per kg. And similarly also find out what is the value of the U2, it is also the wet condition. So du will be equal to 157.3 kilojoules per kg. Now similarly you find out what is the value of the heat passing through the cylinder valves, that is the delta from the first law of thermodynamics, delta Q is equal to du plus delta W. So du already we find out. Now let us find out what is the value of the delta W. So because we are taking in the kilojoules per kg, so that's why we are multiplying with is 100. So by doing this we are able to find out delta Q is equal to 73.84 kilojoules per kg. Next, the last important process is throttling. So throttling is also known as the constant enthalpy process, that is the throttling. So whenever you are having throttling, that is a constant enthalpy process, H1 is equal to H2. So when we are assuming that initial condition is also wet steam and the final condition is also wet steam, then the x2 value is basically found out by using the above formula. Let us solve a problem on the throttling process. So this is the problem. So he has given P1 is equal to 11 bar, the dryness fraction 0.9. So initial condition is the wet steam, and P2 is equal to 1.4 bar. Now he is asking what is the final condition of the steam. But he is saying that is a throttling process is taking place. That is H1 is equal to H2. H1 is equal to H2. The throttling process is taking place. So to find out this particular one, go to the steam tables at a pressure of 14 bar, because he has given P1 is equal to 14 bar. So write down what is the value of the HF and HFG1. And similarly at the final pressure 1.4 bar also you find it out, HF value as well as HFG2 value. So now equate the equation. Let us assume that final condition is also the wet steam. Then the x2 will be equal to 0.96. So it is lesser than 1. So we can say that. So it is basically the wet steam. So x2 is equal to 0.96. That is, it is using the steam tables. And now it is using the Mollier chart. That is, locate point number 1. So because the throttling is nothing but is a constant enthalpy, so just you draw a horizontal line till it meets the next pressure line. So point number 1 and point number 2, you know. So from this particular one, we are able to know that the H1 is equivalent to H2, and here you are able to know what is the value of the S1, and here you are able to know what is the value of S2. So from this particular one, we are able to know what is the dryness fraction of the final condition of the steam, and it is the initial condition of the steam. So based on this important theory, now you should be in a position to answer the important objective type of the questions which were asked in the previous GATE and IES examinations. So just you note down your answers, then finally you compare with the answers which are given. So totally 10 questions I am giving it to you. So now you answer on your own based on the theory, whatever I told you in this particular CDT and in the previous CDTs, and now you compare with this particular the answers. So if your performance is above 60, then it is well and good. So if it is lesser than 60 percentage, then you have to improve a lot. So once again, you go through the slides and read the fundamentals once again and try to solve this particular important aptitude type of the questions. So we'll meet you in the next class. So thank you for listening this important lecture. Thank you.